Everyone, I am Hong Shenling. Student ID is 1080410, and today I am showing you guys a problem in midterm exam because the midterm exam is very hard. So I will show you guys how to do it in an easy way. Okay, let's see. Problem 2 is this one, and the problem asks us to find the partial x and partial y, and by definition in y of f of x function, the dy dx equalize to limit when x close to the x now, the f of x changes. Like in this graph, when the x is closer to the x0 and the f of x minus f of x none is equals to the dx dy, and we can write the x equals to x0, and we can alternate into a character h. When h close to 0, that means the distance between x and x0 equals to near the 0. So we can change the functions above into the x0 plus h, which is the distance between x and x0, and the f of x0 equalized to the f of x0, and the x of x0 we can change to the writings like the h, and that is the two-dimensional definition of the dy dx. Now, as for the three-dimensional, we can write also as like the two-dimensional. That means when there is a partial derivative of x, we only need to see the changes in the x and not dy. So we write f of x plus hy minus f of xy divided by h, which is the limit h equals as close to the 0, which is the questions have told, when x, y are not equals to 0, 0, but very close. So the h is nearly 0, 0. Yes. So in this question, we can first find out partial derivative of x. That is f of x xy equals to limit h close to 0, and f of x plus h 0. Hey, sorry, I made a mistake. I'm new here, so it's very common to make a mistake. So when there's partial of x, partial y, there is x plus h, and y y y 暂停 Okay, and the part above is all right, is have no fault. But in this question, I made a mistake. The f of xy equals to 0 and 0, and x is nearly to 0 to 0. So there f of x plus h equals to 0 plus h, and y0 means 0, 0. And minus f of 0, 0, and below divided by h. So that means we have to calculate limit x is close to 0, 0. Sorry, h close to 0. Sorry, my bad. I'm newbie. It's close to 0. Shit. Good. And we have to calculate 0 minus 0 divided by x squared, h squared minus 0, 0 and h. That means we can get limit h of h close to 0 and h is 0. Next, we can see the question f of xy, partial derivative of y. By definition, the limit still the same, h close to 0 and h. This time, the x did not move, x0. The y moved a little bit. Minus f of x0, y0. Yes, good. So, in this question, we can write simply as this one, h, which is very close to 0, and f of 0, 0 plus h, which is y plus h, minus f of x0, y0, which is also 0, 0. So we can get limit h of h close to 0, h, and this time 0 minus 0, h squared minus 0, 0. That is limit h3 and 0, which is also 0. And now we finish the question 2. So thank you, Professor Huang. Bye bye.